Hey everybody, all the videos in this series are going to be like a continuation of one after the other, and this one's no exception. So this one is basically an example of, we're talking about velocity graphs and how the area underneath the velocity graph is equal to the displacement of the object, how far it moved to the right or to the left. So this is just two examples. This is just me explaining that with a constant velocity. The next video after this one is going to be accelerated motion, where the problems start to get more interesting. Okay, so tune in, enjoy the video, like and subscribe if it helps you, and here we go. All right, let's talk about what we have here with this velocity graph, okay? So now we're gonna take this a step further. We're gonna start looking at what happens when there's an acceleration involved and how do we solve these more difficult problems. So right now, let's look at a pretty straightforward one. So on the left here, I've got a velocity graph. And basically what that's saying to me is this axis is time, this axis is velocity. So remember that y-axis is not telling me where I am. It's not saying I'm at 2 meters at time 0 and 1 and 2. It's saying that I'm moving 2 meters per second. So that never changes. So basically what I got is in 1 second, if I go for time 1 second, my velocity was 2. And that must mean I moved 2 meters per second for 1 second. So I moved 2 meters. And if I look at this on my position graph over here on the right, that means 1, 2. This is a position of 2. And during the course of 1 second, I moved 2 meters to the right. And now I'm here. So this would be at time 1, and I would have started at time 0. Remember, on the position thing, the picture that I have there on the right, you can't really see time. Okay, so now we did 1 second. Now if we do 2 seconds, right, if I go another second, that means I'm going to move another 2 meters. And I'd also like to point out during the first second, when I moved these first 2 meters, that's also equal to the area underneath that velocity graph, which is a 1/2 rectangle, and that's 2. And that numerical value for the area matches the numerical value for the distance that I went. So now in 2 seconds, if I go from 0 second, or if I go from 1 second to 2 seconds, I'm going to go 2 more meters, as is indicated by that area. But that means, so 1, 2. Now I'm at 4. So this would be, I'm here when the time is equal to 2 seconds, and I moved another 2 meters, right? So I moved a total of 4 meters from time 0. And if you look at from time 0, the area under the graph is now a square that's 2/2, so that's 4. For 3, I'm going to gain 2 more meters, so 1, 2. I'm going to be now at place 6 when the time is equal to 3, so I move 2 more meters. And the point here, there's 2. Basically, if you say to me, all right, from time equals 0 to time equals, let's say 3, how far did I move? Well, one way to do that, I'll change colors here, is you can figure out what is the area underneath the graph for that amount of time, 3 seconds. And then the velocity is defined to always be 2, so that area would be equal to 6. So that means I would have moved 6 meters because the distance matches the area. What you also notice is that every second I accumulate an area of 2. In the next second, I accumulate an area of 2 again. In the next second, I accumulate an area of 2 again. If I went from 3 seconds to 4 seconds, I would accumulate an area of 2. So the amount of area I accumulate every second is equal to the amount of distance that I travel every second. And since the velocity is positive, that indicates that I'm moving to the right. Had the velocity been negative, we'll take into account these examples a little bit later, but then I would have just been moving to the left, but I would still be moving with the same speed. All right, let's actually look at a problem, okay? And let me explain how sometimes you're going to see notation, what those things mean. So what I have here is, if you look to the left, I have a velocity graph, and it's saying the velocity is a constant 4. Now remember, that's a constant 4 meters per second. I'm not at 4 meters. My position's not 4. In fact, this velocity graph doesn't tell me where I am, where I start with. It tells me none of that. Now if you look at the right, I've got an x-axis there, and my particle is located at 6 meters on the x-axis. So this is the particle right there that's going to move. And when I say x of 0 is equal to 6 meters, what I mean is on the x-axis at time 0, my position is 6. A lot of times you'll hear your physics teacher refer to this as your initial position. Okay? So It's your initial position because the time is 0, and when the time is 0, that's when you're starting. So my initial position is 6. Now let's say I ask this question. How far will this object move, and which way will it move in, let's say, 3 seconds? Okay, so at t equals 3, find distance traveled. I'm sure I could figure out a better way to word that, but that's good enough for now. So let's look at this. What I got is I want to go at 3 seconds. So if the time frame is 3, if I calculate the area under that velocity graph from 0 to... So if the time is 3, if I calculate the area under that velocity graph, what I end up getting is, let me highlight this, I get all this. This is the area I'm looking for, but it's really just finding the area of a rectangle. Okay? And that is what this basically says. I'm making a short story very long. What that basically says is this area turns out to be 12 because it's just a 4 by 3 rectangle. But if you think about it, every second I accumulated 4 meters, right? 4 meters per second, 4 meters in each second. And that equates to me finding the area. So I end up getting 12. So what does that 12 mean? Well, that means from wherever my position is, I have to move 12 meters to the right. So this time, t equals 0 to t equals 3, I end up moving 12 meters. So what would be 12 meters to the right of 6? That would be 18. Okay, so you have to be careful now when you answer the question. I said at time t equals 3, how much distance did I travel? Well, the answer to that would be 12. I moved 12 meters to the right. Now, the way again, as we go through the examples, the terminology will become clearer. So basically what I just found was my displacement. Okay, displacement. So let's just say this now. Displacement is where you are relative to where you were. So I was at position 6, and now I'm at position 18 because my displacement was 12. And keep in mind, whenever you find the area under that velocity graph, you're finding the displacement. Okay? So in the same way, this segment right here represents my velocity. And let me change color. This segment right here represents my time. Well, now we just have another thing to represent in our picture. The area of that graph represents my displacement. In this case, how far I moved to the right. Now, so the displacement is 12. Another question that's a good question to ask is, what's my position? All right, so that would be like a question that says more like, what is x of 3? In other words, what's my position on the x-axis when the time is equal to 3? And the answer to that would not be 12. It would be 12 plus whatever my starting point was, which was 6. So you're always, to find your position, you have to find your displacement and then add that into whatever your initial position was at time 0. Or there's other cases where you're given it at other times.